Hi guys, welcome back. So yesterday what we did is we reviewed right triangle trig, identifying sine, cosine, and tangent, something you've done before, but also identifying the new three trig functions that you weren't comfortable with and haven't kind of seen before, which is cosecant, secant, and cotangent. Okay, just a quick review. Sine and cosecant kind of go with each other. They're just kind of inverses, they're flipped. Cosine and secant go with each other, and tangent and cotangent go with each other. Today, all we're going to focus on are the sine, cosine, and tangent functions. We're going to use those to find the side of a triangle when you cannot use Pythagorean Theorem. Just to recall, up here in pink, Sohcahtoa is a way to remember sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. We're going to need to know Sohcahtoa and kind of recall that in order to find the missing side of a triangle. So let's go down and look at the notes for today. So again, how can you find the angles and sides of a right triangle? Today will just be sides and tomorrow will be angles, and we'll kind of put it all together. So that's the whole essential question for the next 2 days. And this is like the bottom half of your worksheet. So on the bottom half of your worksheet, it's asking you to find all sides and all angles. After today's lesson, you'll be able to find all the sides. After tomorrow's lesson, we'll help you to find all the angles and be able to put the two together to solve for everything on a triangle. So let's look at this problem right here, example 3. So example 3 gives us a right triangle. It says, okay, let's find the missing side length. Well, the first thing you need to do on this right triangle is 30 is your given angle. So 30 degrees is my given angle, okay? So everything's going to be based off that. So if that's my given angle, then this here is my hypotenuse. My hypotenuse is always the longest side. It's always the diagonal. It's always the angle straight across from the right angle side. So if you draw a dot in the middle of the right angle, and go straight across, that's always going to be your hypotenuse. The opposite side is the side across from the given angle, and the adjacent side is the side next to the given angle. Okay? So the first thing you always do when you're solving is you want to identify your A, your H, and your O. And then we have our Sohcahtoa, which we're going to look at all the time until we get comfortable with it, to let us know which trig function we need to use. So I look at my triangle and say, okay, I'm looking for an A and I have my H. So I look through and say, okay, what trig function has A and H? Well, it has to be cosine. So that's what you want to do every time. Label your sides on the triangle. Okay, what do I have? What am I looking for? Okay, now what trig function goes with those? Again, I have an A. I'm looking for my A, and I have my H, so I'm going to use cosine. So when I do that, I have cosine of my given angle, which is 30 degrees, equals adjacent over hypotenuse. So before we go any further, you've got to make sure your calculator is in degrees. So if it doesn't say DEG at the top, so if it doesn't say DEG or D or something like that at the top, then you might be in radians, and it's going to give you a radian measurement. So not a wrong measurement, just something indifferent. So you got to make sure you're in DEG before you go any further. Okay. Then from here, what are we going to do? Well, I'm going to solve for x. So the first thing I'm going to do is multiply both sides by 8. So I get 8 times cosine of 30 equals x. I would suggest putting that 8 in front of the cosine, because sometimes when you put the 8 after the 30, it gets messed up with that 30. It becomes 38 or 30 times 8. So just make sure, I would suggest to put it in front. So if I type that in my calculator, 8 times cosine, okay, of 30, I end up with x is approximately 6.9. Now with math, how do we round that? So normally the universal rule when you're finding side length is you round to the 10th. Okay? So whenever you see my keys or anything like that, when you're talking about side length, So when you're talking about side length, you round the side length to the nearest tenth unless the directions say otherwise. When we talk about angles tomorrow, you always round angles to the nearest whole number. Again, side length to the nearest tenth. So this would be 6.928, which would round to 6.9. So that would be our x. Okay? Now say, hey, I want to find the other side. I want to find my opposite. I could use right triangle trig again and use sine. Or I know two sides now. I know that my hypotenuse is 8. I know that my adjacent is 6.9. So I could also use Pythagorean Theorem to find the other side if I really wanted to. And that would look like, let's say, I'm going to put x there, x squared plus 6.9 squared equals 8 squared. And I could solve that to find the third side of the triangle. I would always suggest, once you find two sides of the triangle, always use Pythagorean Theorem to find the third side. It's just kind of easy and something you guys are more comfortable with, okay? And when you're talking about side length, round it to the nearest tenth. Don't leave it as an exact answer. You can always round. So let's look at this last one we're going to do today, right here. So it says find the measurement of each side indicated. So they gave us one side, and we're looking for the hypotenuse. So first thing before I do anything, what I'm going to do is I am going to label my triangle. So that 30 right there is my given angle. Right across from the right angle is my hypotenuse, always. You can draw the arrow if it helps, but you don't have to. Next to my 30 degrees is my adjacent. And across from my 30 degrees is my opposite. So again, I write it out every single time because the more you write it out, the more helpful it is and the more muscle memory it'll become. Sohcahtoa. So what do I have? What am I looking for? Well, I have an O, okay? So I have my O, and I'm looking for my H. I don't really care right now about my A, so sometimes I have people cross off what you don't have and you're not looking for. It kind of helps to narrow down your focus. So O and H, and I go up top and I say, okay, which trig function up top goes with O and H? Well, that would be sine. Okay? So I plug this in. So I go sine of 30 degrees equals opposite over hypotenuse. Beautiful. So we set it up just like we did the other problem. However, we're going to notice before there was a variable in the numerator. Pretty straightforward. We multiply by the denominator. Even though there's a variable in the denominator, we still multiply always by the denominator. Now, is that going to look a little weird? Yeah. But once you write it out as x times sine of 30 equals 14 because those x's cancel, from here you guys got it. So how do I get x by itself? Well, I divide by sine 30, but what I do to one side, I have to do to the other. Now, when I'm entering this in my calculator, again, I have to be pretty cautious to make sure I enter it in correctly. Those are going to cancel, so I get x is approximately. I need to do 14 divided by. I'd make sure you have enough parentheses around everything so your calculator is not going to confuse it and somehow mess up with that sine in 30. And when I divide those out, I end up with 28. Okay, and actually this wouldn't be an approximate sign because actually it's exactly 28. The approximate sign would only be used for decimals, but if you don't put approximate sign and put a equal sign there, absolutely no big deal. Again, let's say they're like, hey, I want you to find all the sides. Okay, so I would do 14 squared plus my other side length equals 28 squared. I know that if I solve that, that x has to be less than 28 because the hypotenuse has to be the longest side. So if you're ever doing math and it doesn't work out where the hypotenuse is somehow smaller than the rest of the triangles, go back and check your math because somewhere there was an error, okay? So that's all we're doing for today. If you want to come down here and try a few of these problems, absolutely go ahead. Number 5 would be a great one to do, but what I would do there, instead of doing 3 root 2, I would work to see if you get the answer approximately 4.2. So 3 times root 2 gives you 4.2. But I would definitely try number 5. And then you could try number 6 and 7, do a bunch of things like that, and just see, can you find the sides? Again, tomorrow we'll talk about angle measurement and solving for a whole triangle. I hope you guys have a great afternoon. If you have any questions, I hope to see you on Zoom. Thanks for stopping by.